managing risk in projects, large and small. I hope that folks online can hear us. I think you can. Today, we're going to hear from Michael Loyselle, which many of us know with Federal Highways, Steve Nicaise with Parsons, and Junell O'Donnell with Parsons. I'm not going to read their bios for the spirit of time. Those are on the app. You can check those out, and they may talk a little bit about themselves as we go, but let's go ahead and get into things. Yes, yeah.
Thank you.
Yep.
Taylor. Good morning, everybody. I'm Michael Loyselle. I'm with the Federal Highway Administration. I'm the Major Projects Engineer and lead for the I-69 ORX project in Kentucky. And today I'm going to share some introductory remarks, why, and the utility of why we're doing this. Managing risk in projects, we need to conduct what is called a cost schedule risk assessment, and that is codified in actually the acronym is CSRA. The CSRA is actually part of an entire process that we devised that is also codified in Title 23, Section 106, H and I, for projects that are over 100 million or more in terms of the total cost defined by the NEPA action. The CSRA is conducted to help develop an initial finance plan, which is a requirement based upon the statutory language that I shared before. In this case, where the project sponsors are pursuing a project over 100 million or more, they're required to submit to Federal Highways financial and management plans for approval for 500 million or more prior to federal funding for construction, demonstrating that costs have been estimated as accurately as possible, that risks have been carefully considered and mitigated, funding requirements and strategies have been clearly defined, and that the project role, responsibilities, and processes have been identified as well. What do we use? Federal Highway, what do we use the CSRA for? The cost schedule risk assessment, of course, is to lead the development of the initial finance plan. That is a requirement, federal requirement. But what do we use it for? We use it for two purposes. We use it to assess the major projects sponsors, cost estimating, the schedule, and the risk assessment methodology. We also use it to assess the information to support the development of the major project's initial finance plan. For those of you that are familiar with major projects, CSRA is the new name of what we used to call cost estimate review. We are emphasizing that it's not only cost that we're looking and assessing, but also schedule and risk. So what do we do at a workshop like this for projects that are over 100 million and more? Multiple risks are identified, and you're going to hear some of this in the presentation that Nicaise and Junell are going to present to you for the ORX. Multiple risks are identified, and they are assigned a cost range and the probability of occurrence. Base cost are strips of contingencies, and the CSRA process adds back an appropriate contingency based upon a systematic risk assessment. And then the risks are identified in the workshop are analyzed using the Monte Carlo simulation. That is a probabilistic risk estimating simulation method. We look at the 70th percentile cost and schedule. We look after a risk register developed by the project sponsor and a table identifying the top 10 risks for the major projects that are over 100 million or more, and the 500 million that are defined major projects. With that, I'm gonna leave you with the group so they can share with you the story on ORA. Thank you.
Thank you, Michael. So we're going to talk about the risk assessment on the I-69 Ohio River Crossing Project, ORX. And first, I'll give you a brief overview of the project itself. ORX connects existing sections of I-69 in Kentucky and Indiana. Currently, the I-69 ends short of the river in both states. And traffic uses the US 41 bridges to cross the river. So this project will complete approximately 8 miles of new alignment to cross the Ohio River just east of the existing US 41 bridges, about a mile to the east. And it services the cities of Evansville, Indiana, and Henderson, Kentucky, as well as the I-69 corridor itself. I-69 has been largely extended through Kentucky through parkway upgrades already, as well as new alignment sections in Indiana from Evansville north to Indianapolis is nearly complete. So the risk assessment process and the cost estimate review we went through the spring of 2021. And we'll talk about how the risks were developed and discussed in the process and how they were all aggregated together to come up with this 70th percentile number that Michael talks about. It's kind of unique if you haven't been involved in a major project cost estimate review. You'll learn something, and the processes themselves can be applied to any project. So it's important to take that away to understand how this could apply to your project. So Junell is going to talk about the preparatory work that we did for the workshop, and then I'll finish up with how the workshop went and what the results were. So Junell.
So like Steve said, I'm going to mention some general things here up front that can be used really on any project. It doesn't have to be 500 million or more. We, as a result of using this process on these larger projects, have actually really seen a lot of benefits in pulling these into even smaller jobs when they either have a design build aspect, something unique, something especially risky. So these first couple slides are really going to hit home on a couple of items that you could use on really any project. First is a project team workshop. These begin, the very first one is early in the project, ideally during procurement, during the planning phases, this can be implemented. The project team workshop needs to have disciplines from throughout the design, the procurement, the contracting, finance. You need to have your subject matter experts from really each of the disciplines involved in this conversation as you pull together the initial risk register. And the result of this is to supplement your estimate and your schedule going forward and really itemize the lists as you move forward and make sure that you're mitigating them or avoiding risks to the best extent possible for the project team. So as was mentioned, this process was used on some of the larger projects that you're all familiar with, the Madison Milton Bridge, the Louisville ORV. We're also using it on the I-69 finish line corridor right now in Indiana. And as I said, I've used it on some of our smaller jobs. The very first Pell we just finished, we were able to use some level of risk management along these lines. And also the first Tismo job is underway. So these are things that could really be implemented, and we're seeing benefits from across the entire project life. So the risk register itself is really, it's a table of risks. So you itemize by individual risk description, the likelihood that it's going to occur. You can put in, and certainly when federal highway is involved and it's a required process, you need to understand what the likelihood is of a high and low estimated effect on the project or cost, and then also some understanding of schedule. So is the individual risk going to If it goes unmitigated, could it be an effect of, a month on the schedule, or could it be a year? So that's where you itemize by line, what could be the impact. And then the mitigation strategy is important here. So this is a living document. This is something that you can carry throughout the entire life of the project, all through construction. What we typically do is after this first register is developed, I'll usually open up another tab each time we meet. So the regularity is dependent upon your project. We very often will set up either a monthly or a bi-monthly call, and that includes all of the project partners and disciplines, and we're regularly updating this. So by the time that you're moving through the project, some of those risks should fall off as you mitigate through contractual terms, through design, that sort of thing. So this is a very simplified risk register. The ones that we pull together for the actual estimate reviews for federal highway are much larger. They have many, many columns, but this is a simplified version that I would use on, say, a design build that's under $100 million. And it's something that just makes the process of managing risk very, very intentional throughout the life of the project. So for the federal highway cost estimate review, these are some of the items I'll run through, but project documentation is the first. You're not supposed to be able to read the slide, but the point is there's a lot of work that goes up front before you sit in front of the federal highway and pull this information together and get to the modeling. So you need to understand your project schedule, have a fully built out schedule, a fully built out estimate to the best of your ability, the risk register, the plans, any kind of procurement documents, any kind of documentation regarding the unique features of the project, all need to be pulled together in advance of this meeting. And all of the attendees need to have time to review them, and everyone come to the meeting prepared to discuss very specific risks and what we can do about them during the project to mitigate. So who's involved? Again, federal highway for the CER process that we did last year, federal highway, KYTC, and NDOT were all involved, as well as the consultant team. So that includes all of the technical disciplines. We had about 50 attendees in this one meeting. So as you can imagine, there are a lot of meetings that lead up to the big CER meeting. There's a lot of work pulling together and making sure that you're not looking at any of those risks for the first time when you get in front of federal highway. So it needs to be a thoughtful process in advance of this effort. And then the actual agenda for the review is typically 4 days. For us, it was 4 days on ORX. 30 days prior is where you need to have your team orientation, have your project documents together. Day one is your project overview and your CER model overview, which Steve will talk about some more here. 2 and 3 are technical topics, talking about the quantifiable risk, the probabilities, and the impacts. And then day 4 is a closeout presentation where we discuss the findings from federal highway, and they give a review of what we have done and their opinion of how we should take next steps and move forward. So a basic concept of this process is that throughout the life of the project, as you go from planning through design, through final design, and then construction, your risks should become fewer and should become better understood. So you have your base deterministic estimate, and then you're building your contingency using the risk register. So the base variability is your inherent risk. It's caused by events that are unknown to the team, and it's a function of the level of design and estimating that you're able to do that early in the process. And then the risk portion is the uncertain events. So the threats, the opportunities, which sometimes gets lost. It is a risk register, but if there are opportunities, if there are items that we see as ATC possibilities, or we see opportunities for the design build teams, or we want to build those should also be captured in the risk register as a positive potential cost or a positive schedule impact. So the uncertainty portion of it is the base variability plus the risks, then market conditions, and the inflation variability. And these are all items that are built into Federal Highways review and are understood within the model, so that we can have an output that is a thorough review of the estimate and schedule. So the base variability is where the model will run different likelihoods, different scenarios, and give a most likely, a minimum, and a maximum based on a triangular distribution. Then the risks, based on the likelihood of occurrence, you also get an impact of occurrence and a distribution with the most likely, minimum, and maximum for each one of those risk lines. I'm gonna go ahead and turn it over to Steve. He'll get into some more detail.
Thank you, Junell. So. Okay. So in the CER review process, we talked first about the cost estimate and about what's in there, what's not in there. And in that discussion, we be sure to strip out any contingencies and quantities, and costs, and inflation or pricing contingencies. And those are pulled out, held separately. And we make those adjustments up front. And then for each line item, we talk about our major line item, say bridges, roadways. We talk about what is the potential for this cost to, you know, how accurate is this cost, plus or minus what? The most likely cost is 50 million, and what is the downside? Maybe minus 5 million and plus 15 million, something like that. For each line item, we go through and we identify that range. And then we talk about the market, you know, what is the market? Is it very competitive? Will we have lots of competition? Is the market saturated? Will we have less competition? What's the effect on the project? And then the risk events. In the case of ORX, the major risks were flooding risks and also geotechnical risks. And then the Monte Carlo simulation is kind of a unique feature of this process. You know, many simple risk registers will just add up the potential costs and say, well, you know, the total risk is the sum of the average. But you may be getting a misunderstanding of what the actual risk is. What's the likelihood that every risk is going to occur on the project at the average level? What the Monte Carlo simulation does is it takes those triangular distributions that we talked about, and it says, okay, it's going to generate a random number between 0 and 100, and then go into that triangular distribution and pick a number between 0 and 100 on that scale and apply that in that simulation. And it does this for each risk multiple times, thousands or tens of thousands of times, to develop a bell curve of what the total sum of those risks might be. And on that bell curve, they go to the 70th percentile, and that's the magic number. And we'll show a few things to demonstrate that. I'm not going to go through the CER observations here. We had a successful meeting. The result showed in the this is the baseline estimate, 1.1 billion. Some of the things that were noted in here is our schedule. We had quite a lot of schedule risk because of flooding, both in all the sections really. And so we adjusted the project schedule accordingly by a number of months. And also the project estimate was more or less confirmed. When this was prepared, we were looking at the project in two sections, section 1 and 2. Section 1 was the Kentucky approach section that was currently under construction. Section 2 was the balance of the job north of section 1 across the river into Indiana. Section 2 has since been split into two sections, section 2 and 3. Section 3 is just getting underway, the Indiana approach, and there will be a procurement on section 3 in 2023. But we looked at what is the base cost variability. On section one, we felt it was 8% overall. That was the result of the workshop. In section two, it was slightly higher at 10% because of the type of work and the time to execution. We also had inflation numbers and market conditions in here. In section one, the significant risks identified. Top one was design development risks. You know, we were early in the design process in section one. We still had preliminary design to do, and then the procurement process. So that was a significant risk. Flooding, Canoe Creek runs right through the center of the project and affects probably half of the alignment or more of the new alignment section. So that was a significant risk. This area has very high silt, deep silts, saturated silts. So the geotechnical risks were significant both for settlement, earthwork, and workability. High groundwater was also, but we also identified ATCs and design build innovations as a opportunity. And as it turned out, that was a significant benefit through the design build procurement process. The selected DBT came in at some 37 million under the 160. So a large part of that was due to the ATCs that they were able to develop. We also looked at schedule risks. You know, oftentimes a risk item may have both a cost and a schedule impact. And so for this process, we looked at those separately. You know, what is the cost and the probability? And also, what is the schedule impact and the probability? And there's a major transmission line that needs to be relocated to enable the section one project. Right of way, a number of large tracts of land needed to be acquired. So that was a significant risk. Flooding, the need for a permit from FEMA for the Walmart for modifying the floodplain and the floodway, and then permit delays. So this is the bell curve I was discussing. It's really a result of multiple model runs of the Monte Carlo simulation. And the Monte Carlo process, as I said, was that random number generator multiplied by your curves from the different costs and schedule discussions. So this is the funded phase for section one, and then the probability schedule, which looked at this is a number of quarters late, so we wound up adding about 9 months to the project schedule based on this prediction. Section 2 and 3 had similar cost risks identified for the bridge construction over the Ohio River. And in this location, the river, the floodplain is about 3 miles wide, so it's all bridge. A little bit of earthwork, but all bridge, and it floods regularly. Every year you can expect at least one flood. There were a couple of years since we've been working on the project. We had 4 or 5 flooding events where the water came up over the banks for a significant period of time. So that flooding risk is significant. It affected Madison Milton Bridge to a large extent. It affected the bridges in Louisville multiple times, and we expect it's going to affect this project as well. So significant cost risk due to and schedule risk due to flooding. The bridge type is still to be determined. The strategy will likely be, as it was in Louisville, to leave that question open for the design build team. Process to establish criteria. Seismic design is a key issue here. We're near the new grid fault. And so the seismicity in this area is very high, nearly as high as San Francisco. So this is a key concern. Also, not just the seismic event, but liquefaction of the soils during a seismic event. Or the highway and the bridges. So we similarly had schedule impacts, and we adjusted the project schedule based on this assessment. So one of the strategies that has been developed since the CER was the schedule risk on section 2 was largely driven by the lack of access to the bridge site. There's no highway access to the bridge site today. It's all gravel roads along the floodplain to get down to the bridge site. In the flooding event, they're not available for access or egress. And so that was one of the reasons NDOT chose to accelerate section 3 was to build the initial section of highway from the Veterans Parkway at the north down to the bridge site to provide a reliable access for construction to build section 2. So the CER recommendations was to use a cost forecast in the FEIS ROD that reflects the uncertainty and complexity of the project. They used the 70% year of expenditure amount in setting budgets, the baseline costs, as well as the schedule. This is a living document, so as we go through each phase of the project and complete a procurement, they'll be revisited and updated to reflect the current conditions. The finance plan was issued in the fall last year, and it will be reissued and updated annually to reflect changing conditions. And it informed the procurement process for section 1. The procurement documents were largely prepared after this CER review. So the terms and requirements in the RFP were all influenced by the risk register and mitigation strategies to appropriately assign the risk to the party that was best able to manage it. This slide shows how the project is divided into 3 sections. Section 1 at the bottom of the screen. Section 2 is the piece across the river, and then section 3 is the Indiana project. So ORX is a major project that requires this process. I was also involved in the ORB process, and we went through 2 process reviews on that project. One before the supplemental EIS and one following. But this process can be called for any project, large or small. So that's the end of our presentation. Ready for any questions that may be out there.
So you said you took inflation into account. What about escalation, all of that? So it's evolving and changing dynamic supply chain, delay, all of that. Even contractors saying we don't have a clue how to project that. So how does that affect the modeling? Do you go back and revisit it based on current conditions?
Yes, we have not done an update this year. I would say we didn't anticipate this level of inflation. Good news was the procurement was completed in the fall of last year, kind of before the peak of this inflation season happens. The price basically got blocked in there. Of course, the pricing pressures affect the performance during construction, and that by itself leads to other risks. So You're right. I mean, the situation we're in now is kind of unprecedented in recent times. I'm sure over the past 50 years, we've seen periods like this before, but certainly not in the last 20 years. Sorry. Certainly not in the last 20 years we've seen situations like this.
But all those items are items individually listed in the risk register, so you have the conversation around it. So for material availability, we talk about, you know, are there lots of other jobs going on that are gonna require MSD panels, for example? And if so, what's the likelihood that that would affect schedule or the cost? We also look at inflation, talk about a likely high or low, talk about what's happening in the world and what's the likelihood that something will happen. We couldn't have captured this. But yes, each one of those items is something that is listed in the risk register. And at the very least, you're having that discussion early enough in the process that it can inform not only the estimate, but also the procurement documents. So no crystal ball, but we do our best.
Give an example of how you scaled the Nicaise down for a project that saves $100,000.
Well, Junell gave an example for one of her projects.
Yeah, so, again, like the making the discussion of risk intentional is why I feel it's so important, because you're always thinking about it. If you talk about it early on, then you can always go back to this register and say, okay, well, we're writing the procurement documents. What are the most important things that we're very careful about the way that we talk about how the risk is shared and what are the things that we can avoid? So this is an example. I know you can't see it all the way, but basically that first column is just the risk number and then the section of the project, you know. Then you have whether it's active or closed. So I would keep this live always and never get rid of anything. So yeah, when you close an item, close it and then filter it out and put it to the bottom, but always keep it, because then if at some point down the road, if one of the agencies wants to talk about, well, how did we get to this solution? You have a record of those discussions. So then you have the risk category, which also is something that is, you know, you can use it to filter it out. And you can have meetings with just the utility people, for example, instead of taking 5 hours of everyone's time. You can set up your agenda so that you're just bringing the utility people in to talk about the utility risks. And then the description of the risks, and here, there's a probability and severity, which I would recommend always keeping, just because it keeps you thinking about, well, is this a 2 likelihood risk or is it a 4? And we use 1 to 4 on both the probability and the likelihood, and then it creates that medium, high, low. And then that next one is a threat or an opportunity, and then your mitigation strategy. So this is something that I would use using on a job that's much smaller, but it's just unique, so that we're always focused on it, where we're not specifically calling out, well, do we think this risk is going to be a $200,000 job or a $2 million job, the way that we would on a major project. On a major project, you're going to get very specific about how high or how low do you think the impact is, both schedule and estimate. It's something, again, you can choose to do as much as you like, but you also don't want to do this full process on something that's a $50 million road and bridge job that has no unique features, because doing the whole effort is something that's probably a little bit cost prohibitive on that type of job.
So you probably don't do the final part.
No, definitely not.
That's the.
Yeah. It's,
So what generates those triangle distributions? Is that an FHWA supply program?
No, that comes out of the project team. So the FHWA will probe the project team and say, okay, what curve best describes the probability here? You know, the most typical one is a triangle that has equal sides. I forget the geometry, but where it's plus or minus 5%. So it's a perfect triangle. Or it could be lopsided if we have a smaller downside and a larger upside. So it would be a little inclined triangle.
I guess I was going with the software side. What what software is generated and run those models, the iteration.
It's the federal highway software.
That's what I'm saying.
Yeah. In fact, I think they used to call it crystal ball. Okay. But, yeah. And then the width of the triangle in dollars and months, that's all coming out of the budget. So when the Monte Carlo simulation runs, it's finding a number that fits within that triangle. Basically, each risk and then adds them up. We talk about risk sharing and how that's done. I'll give a couple examples. If we get time, how much time? A minute? A minute?
No.
Okay, 50 now.
Yeah, you're good.
Okay. So I was involved in the East End crossing and the tunnel that we built. East End, Louisville here. And geotechnical risk in building a tunnel is always a big concern. So the way the risks were managed there was the owner wrote what they call the geotechnical baseline report, which was what the owner felt prudent contractor should consider in pricing the job. We've done explorations, we know what the rock is, but what's the chance of finding a camera? It's more than zero. And if we find a camera, how many cameras might we find? 1, 2, 3. So the geotechnical baseline report set a line in the sand saying you should expect to find 1 cavern or 2 caverns. And if you do find them, those 2, that cost is in your bid. If you find a 3rd, that's subject to a claim. Okay, as it turned out, they didn't find any caverns. They found holes in the rock. They didn't find any large voids. So that was a way of setting the contract to say this level of risk is built into your bid, and anything over it, the owner will cover. To push all the risk onto the contractor would have been cost prohibitive. It would just increase their price so that they be covered in any case. Same thing with the flooding risk. We knew that after Madison Milton had, I think it was approaching 2 years of delay on due to flooding. We knew that flooding was a concern here. And so the owner established a water surface elevation set. If the water surface comes up to this elevation, it was kind of a minor flood event based on the flooding history. Anything below this is on you. Now, when water gets up to that level, contractors had to demobilize and clean all their equipment, tie it off, and couldn't work. But those minor flooding events were built into their bid. The owner only covered flooding costs that floods over the minor flood elevation. As it turned out, we only had one of those, and that was covered in a change order. But that's a way of sharing the risk. The contractor needs to be set up, have the equipment and the processes available to demobilize when the water comes up, and can't all be in a claim. But to put all the risk of flooding on the contractor, just think it's all your risk. Your cost is going to go up. So, what's the benefit of that? And another thing we did on the East End, of course, section 1's a little bit different animal than the East End, but was we knew that there were multiple areas where there were risks, multiple disciplines, utility risks, and right-of-way risks, all sorts of risks. So they set up a relief event allowance account, which was a funded account. The owner put so much funds in there, I can get the number, something like 40 million. I said, this money is set aside to cover claims. Anything that's a relief event, it's set aside. And, in order to claim on this, the loss has to be above a certain threshold. So if it was $100,000, anything less than $100,000, you can't claim. And at the end of the job, whatever's left in this account that hasn't been paid out in claims will split 50-50. So that strategy helped and reduce the number of claims. At the end of the job, $700 million job, very complex. We had one thing. And the balance was split. So if they claim for $200,000, they're actually only netting $100,000 more because they would have got $100,000 in the split end of the job. So that helped, both in the level of cooperation during the job. It was a very successful job in part because we were all aligned in the same direction.
So I was actually on the contractor team that was successful on East End, so I worked on the estimate. And we also put together a risk register. And as a result of that job, moving forward, using it on every major project. And it was something that we, from a contractor standpoint, they're also looking at line items. They're also looking at the contract language, looking at what the benefit is of doing different things during the estimate. So it's something that, the process has been, yes, it was started just on the big projects, just by federal highway, but it's really everyone in the industry is using this type of process just because you see the benefit of coming back to what are the big items, what are the big potential problems that would cause an issue with the job.
On the Henderson project, flooding issue, what's your stimulus, I guess? So how that really could be handled.
College flag on the section 1 project,
But in general, you're gonna have 8 miles of bridge, is that correct?
well, we're gonna have 3 miles of bridge in section 2. And we haven't started the procurement documents on that. All we've done is the NEPA phase and the planning. So that's all stuff that needs to be written as we go. But there's flooding risk in section 1 as well with New Creek. And we do have provisions built into the contract for that. I would say the impacts from flooding and the frequency of flooding at New Creek is less than on the Ohio. It doesn't flood every year. I mean, the water gets high, but once they're out of the ground with their earthwork, pretty much they've passed that phase.
Well, we at Parsons, we also have a group that has a lot of construction experience. They don't work here, but they work elsewhere in the nation and across the world. So we have experts who we can go to and say, we have this very specific instance. This is the likelihood that we think it might flood. What would be the impact on your operations? So we have people who know construction who actually put together a contractor style estimate. Right, it's very early on in the process when we're doing this, but they put together that estimate for us to run it against our typical, bid tabs type of estimate. And then we also have those experts that we can go to do just what you're saying and say, we have this very specific issue. What's kind of the high and the low likelihood, cost, and schedule impacts? And then we just have that conversation and let them tell us, what would you do? What's your experience on this situation? What's the best way to make sure that we're allocating the risk in the contract investment?
Well, that's the question, so situation that needs to be but we got 16 inches of rain in 5 days. That's enough. If that happens in that area there, even if it happens up river.
Right, the risk in, I guess, in New Creek is the local rainfall, so, right. The Ohio River is subject to what happens all the way up to Pittsburgh, I guess, so. Yeah. And when it's coming for a long time. You can see the current building and it's gonna be there. So I don't see any other questions. Michael, did you have anything for closing?
This process that you saw here, delivered for the ORX, as Junell explained, is actually scalable to any kind of project over 100 million or just slightly under 100 million. The significant difference is what we use the crystal ball for. Example that we use to do this type of model. And I mean, I encourage on your significant projects to utilize the risk register to establish a baseline. And begin assessing and identifying those risks early in the project development by the NEPA phase. Besides the environmental side, how can we better achieve procurement documentation for us to be able to get adequate bidding and the competition that we encourage?
Thank you, everyone.
Yeah, thank you.